Step to calculate effective capacitance, charge and potential difference across each capacitor. Step 1. Construct a table with 4 columns. Step 2. Draw from a complicated circuit to simple circuit consists only one capacitor. Step 3. Reverse calculation from lower row to upper row. We want to discuss for the question number 1. The first step, so we need to calculate the capacitance. Okay, before that, make sure we draw how many columns of table here. So this is the first column, capacitance. Second column is a charge, and the third column is a voltage. So first step, we need to construct a table. Next, we need to calculate capacitance by using from complicated circuit. So this is the complicated circuit. Now we need to draw until we get the single capacitor. C1 and C2 actually is a series combination. Okay, so combine C1 and C2, we get a new capacitance here. So how to calculate for the series combination? Okay, this is the equation. And then substitute the value. And then we get effective capacitance 1,2 is 1.33 microfarad. So we can label at this diagram as a 1.33 microfarad. Okay, the third step, okay, after calculate the capacitance, okay, we need to write all the total value here. Okay, mean what? Okay, let's say the total value here 1.33 microfarad for the capacitance. Okay, here the total voltage given is 10 volt. Okay, right here for the voltage column. And then can we determine the total charge here? Can we determine the total charge here? Okay, yes. So by using C equal to Q over V. So here total, here total. Okay, substitute 1.33 microfarad equal to QT over 10 volt. Therefore, we will get the total charge here is okay 1.33 power of -5 coulomb. Okay, so I just highlight for you. So this is the value of total charge. This is the value of total voltage. Okay, next. Okay, refer to the previous equation. Okay, means what? We need to look at the previous equation. So Q1 and Q2 equal to Q total. Meaning, the value of Q1 equal to charge 2 equal to combination them. Okay, so meaning Q1 equal to 1.33 power of -5 coulomb, unit in coulomb. Q2 is also 1.33 power of -5 coulomb. Okay, settle for the each charge of capacitor. Now we want to calculate V1 and V2. V1 and V2 here. This is V1. This is V2. Okay, so now for the series combination. Okay, for the voltage here, V1 plus V2 equal to V total. So means what? V1 plus V2 equal to 10 volt. Okay, so we want to determine V1. So V1 equal to, okay, using the same equation, C equal to Q over V, right? Okay, rearrange. So we get V equal to Q over C. Let's say we want to determine Q1. Okay, substitute the value of Q1 over the value of C1. Okay, where's the value of C1? Okay, C1 here, 2 microfarad. Okay, so we will get V1. So V1 is 6.65 volt. Okay, after we get V1, okay, here V1. So can we calculate V2? Yes, 10 minus 6.65. So we get from here. Actually, we get from this equation here. Okay, therefore, V1 6.65 volt, and then V2 3.35 volt. So by answering the question, calculate capacitance, charge and voltage. Each capacitor means what? Okay, first, this is the effective capacitance. This is the total charge. This is the total voltage. And then this is the value of Q1. This is the value of Q2. This is V1 and this is V2. Question number 2. Okay, first step, construct a table consists of, okay, diagram, capacitance C, charge Q, and the voltage V. This is the step 1. Step 2, we need to draw from the complicated circuit to the single or simple circuit. Okay, so by looking at the C1 and C2 here, so C1 and C2 here actually we can combine as a parallel. Okay, now this is the equation when we want to calculate for the parallel capacitance. Okay, and then we get 5 microfarad. After that, we need to draw a new circuit Okay, to show the combination of C12. So label as 5 microfarad. Okay, next, after that, okay, write all the total value here. For the simple diagram here, so here, so this is the total value. 5 microfarad for the effective capacitance, and then 5 volt. Actually, this is the power supply or total voltage. Now, we need to determine Q total. So, how? By using C equal to Q over V. Therefore, Q equal to CV. Total. So, determine your total charge in coulomb. Okay, next. Looking for the characteristic of the charge for the series. So this is the equation for the parallel combination of capacitor. Q12 equal to Q1 plus Q2. And then for the voltage parallel combination, V12 equal to V1 equal to V2. Okay, so actually V12 equal to V total. So V1 equal to V2 equal to 5 volt. Can we determine V1? Yes, because of equal. Okay, so now can we determine Q1? Q1. So Q1 equal to CV 1 and 1. So where our value for the C1? Okay, C1 here. And then V1 here. Okay, then determine your Q1 in coulomb. Same with Q2. Q2 equal to CV. And then where your C2? C2, 3 microfarad, substitute. And then V2, 5 volt. So determine your Q2 in coulomb. Question number 3. Step 1. Draw or construct a table. Consists diagram, capacitance, charge and voltage. Okay, now we need to calculate the capacitance first. Okay, we have C1, C2 and C3. Okay, which combination are complicated? Which one? The capacitors are complicated combination. This part. So we need to solve it first as a parallel. So, how to calculate for the parallel combination 2 and 3? So using this equation, so we will get 5 microfarad. At the same time, so we need to write for the charge 2 and 3. Okay. Why only 2 and 3 for this row? Okay, why? For this row, only the value of 2, 3. Refer to the diagram. So now we want to solve the problem, okay, related to combination C2 and C3. That's why when you look at this symbol is 2, 3, for this part is 2, 3, for this part also 2, 3. Because of what? Because of for this row, so we want to solve this combination. Consists of C2 and C3. Okay, next, calculate and then draw a new diagram here. So C23 actually 5 microfarad. Okay, C1 refer to this is 1 microfarad. For this combination is series. So this is the series equation. And then substitute for the C1 and C23. Okay, this is the final answer. So therefore, we need to draw the last diagram from the complicated. Here is complicated, right? And then we need to draw until we get the single capacitor. Okay, just write all the total value here. Okay, this is the total value of capacitance we call as a effective capacitance. And then the voltage given, the total voltage is 20 volt. Okay, can you determine the value of Q total? Okay, again, Q equal to CV. So substitute C effective. Effective or we use the value of micro here and then times with 20. So from here we will get charge in coulomb. Okay, after we get all the total value below row, now we need to look for the previous row. Meaning, for this row, so we are looking for this combination, right? Okay. So meaning, for the charge, so we can state Q1 because of series equal to Q23, am I right? So equal to Q123, am I right? So actually Q123 is Q total. So we just state Q1 equal to Q total. Q2 equal to Q total. So where your Q total? So this is your Q total here. Okay. Then write and then write in coulomb. Okay, now we need to fill up to calculate the voltage. So for the voltage, series V1 plus V23 equal to V123, right? So V1 plus V23 actually equal to V total. V total means, where your V total? Here, 20 volt. Okay, so can we determine V1? Q1 over C1. So where your Q1? Q1 we get from this column. And then where you C1? The value of C1 here, 1 microfarad. So we will get V1 in volt. After that, can we find or calculate V2? Yes. Okay. Oh, sorry. Can we get V23? Okay, yes. Okay, next. Next. So refer to this. Refer to this previous row. Row. Okay. So Q23 equal to Q2 plus Q3 because of refer to this combination. Right? Okay. So Q23 actually, where you go Q23? So this one actually 3 Q23. Okay. So we get Q23, okay, from below row. Okay. Then Q2 plus Q3. Okay, can we determine Q2? Q2 equal to C2V2. Okay, so where you C2? C2 here, 2 microfarad. And then where your V2? So refer to this equation. Okay, V2 equal to V3 equal to V23, right? Okay, V23 we can determine from here. So actually we can find V2 in volt and V3 in volt. So we can determine Q3 equal to C3 V3 also in coulomb.